Today, we will use a scientific perspective to explore the complex truth behind meteorological events. According to the latest news from ABC, as several rounds of extreme rainfall swept across Southern California, an incredible scene occurred in the Death Valley Desert National Park in the United States. The lowest point in North America, the basin is often a surreal expanse of dry salt flats that stretches as far as the eye can see. But on this day, the longtime area resident was startled by what he saw as he approached. As the hottest and driest place in North America, billions of gallons of water suddenly appeared in the Badwater Basin of Death Valley. What is even more exaggerated is that a natural lake was formed. Rainwater in Death Valley usually evaporates quickly, but this billion-gallon water is now a 6-mile-long, 3-mile-wide lake called Lake Manly. A stunning series of satellite images captured by NASA contrast the desert basin before and after recent rainfall, showing sapphire blue waters surrounded by miles of arid, barren mountains and desert dunes. As rain repeatedly soaks the area, the lake's depth has increased to about a foot, meaning it has just enough water for an activity that sounds out of place in the notoriously arid landscape of the Death Valley Desert. Kayaking. Death Valley doesn't receive much rainfall, but thunderstorms can occasionally cause flash flooding in the park, according to the National Park Service. Located at the very bottom of Death Valley, Badwater Basin is the remnant of a massive ancient lake that once existed tens of thousands of years ago. Rainfall typically averages only 2 inches per year. But over the past 6 months, the bottom has dropped nearly 5 inches. Most of the rain once flooded much of California, according to the National Park Service. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. Experts remain baffled as to why the lake lasted for so long, citing significant anomalies compared to previous observations. Despite the lack of historical data on the lifespan of such short-lived lakes, the persistence of Death Valley's current body of water is a reminder of nature's ability to surprise and exceed expectations. According to Guinness World Records, the hottest temperature in the world was officially measured on July 10, 1913, when Death Valley reached 134 degrees Fahrenheit. Located in a place emblematic of extreme drought, this ephemeral lake reminds us of the power and unpredictability of weather phenomena and the importance of monitoring and studying these anomalies to better understand Earth's complex environmental dynamics. In recent times, the western United States has been hit by frequent floods. Among them, our channel reported on February 5th that deadly storms caused severe chaos in California, bringing record rainfall and strong winds. More than 120 mudslides have been reported in Los Angeles, damaging about 25 buildings. Nearly 38 million people across the state and Arizona are under flood warnings, including about 10 million in Los Angeles County. The storm killed at least 3 people, all struck by trees that fell in the bad weather. Officials warn that dangers still lurk in waters that continue to rise. As of Monday afternoon, the storm remained stalled in the Los Angeles area, and forecasters warned that persistent rain, with about a half-inch an hour, would intensify again throughout the afternoon. Storms continued to batter the area on Tuesday, the National Weather Service said. The storm has dumped staggering amounts of rainfall so far, with some areas of Los Angeles receiving totals of more than 10 inches. UCLA climate scientist Chad reported that UCLA, on the city's west side, received more than 11.8 inches of rain, more than 3 times the average rainfall for the entire month of February. Thank you for liking, leaving comments, subscribing and turning on the little bell. We will update every day. Streets in a steeply hilly Los Angeles neighborhood turned into fast-flowing rivers overnight as some residents scrambled to evacuate. Clothes, books, and even refrigerators tumbled down roads alongside debris pulled from damaged homes as mud flooded millions of dollars worth of homes in the Beverly Crest neighborhood after 2 landslides. As the storm lingers in the Los Angeles basin, officials are particularly worried about the Santa Monica Mountains and the Hollywood Hills. Early Monday morning, the National Weather Service's Los Angeles station warned that extremely hazardous conditions were occurring there. In the Hollywood Hills, a resident of Caribou Lane said an entire hillside collapsed, pushing the house into the road and crashing into neighbors' porches and driveways, trapping several people. As of noon Monday, the National Weather Service reported that Topanga, Ber, Sepulveda Canyon, and Woodland Hills had all received more than 10 inches of rain over 2 days. The temperature in downtown Los Angeles is approaching 6.5 inches and the rain is still falling. Los Angeles Mayor Karen Bass said at a press conference on Monday that it was a difficult day for our city. California Governor Gavin Newsom declared a state of emergency in Los Angeles, Orange, Riverside, San Bernardino, San Diego, San Luis Obispo, Santa Barbara, and Ventura counties. This is the second storm to hit California in less than a week. The system made landfall Sunday afternoon, whipping up damaging wind gusts and dumping rain and snow along California's northern and central coasts, prompting the National Weather Service to issue a rare hurricane warning. An elderly man in Yuba City, Northern California, was killed when a redwood tree fell in his backyard. According to reports, a tree fell on a house in Boulder Creek, a small town in the Santa Cruz Mountains, on Sunday. The sheriff's office said the resident was trapped inside the home and died at the scene. One person managed to escape. Elsewhere, authorities in Sacramento County said a 41-year-old man was killed after being hit by a falling tree on Sunday as winds neared 70 miles per hour. Strong winds knocked down power lines Monday morning, knocking out power to 500,000 homes and businesses. By the afternoon, utilities were making progress restoring service to affected areas, but about 379,000 customers were still struggling. Wind speeds exceeded 60 miles per hour throughout the San Francisco Bay Area, with gusts exceeding 80 mph in the mountains. Heavy rainfall flooded streets and high winds downed trees and power lines. In the technical center of South St. Joseph, emergency services rescued stranded motorists from flooded cars and from homeless encampments along swollen rivers. As the storm moved south, officials warned of devastating flooding and ordered evacuations in canyons where recent wildfires were burning and where mudslides were at high risk. In Santa Barbara, which was hit by mudslides in 2018, schools were closed Monday. Evacuation orders and warnings are in place for mountain and canyon areas in Monterey, Santa Barbara, Ventura, and Los Angeles counties. California is located on the western coast of North America, facing the Pacific Ocean, and has a Mediterranean climate. The region has wet winters and dry summers. Pacific high pressure often affects this region, forming a stable subtropical high-pressure system. However, due to the influence of ocean currents and lower-level water vapor, the coastal areas of California will still be affected by some storms. First of all, California is located in the Pacific Rim seismic belt, where plate movements are frequent and earthquakes and volcanic activities are relatively active. This provides favorable geological conditions for the occurrence of natural disasters such as hurricanes. Secondly, California is close to the Gulf of Mexico and the Pacific Ocean, both of which are major generating areas for tropical cyclones. If a hurricane-level storm originates from the eastern Pacific or the Gulf of Mexico and moves northward, it is likely to hit California. In addition, climate anomalies such as El Niño and La Niña will also trigger abnormal atmospheric circulation in California and nearby waters, increasing the possibility of hurricane landfall. In addition, California is located at a low latitude and belongs to the subtropical high-pressure belt. Both the south and north of this high-pressure belt are low-pressure troughs, which are conducive to the generation of tropical cyclones. If a tropical storm in the eastern Pacific or Atlantic moves northward into the edge of the subtropical high, it may affect the California area. Finally, there are powerful ocean current systems in the ocean surrounding California, such as the California Current and the Arizona Current. These currents provide the ocean heat and water vapor conditions needed for natural disasters such as hurricanes. If an El Niño event occurs, ocean warming and atmospheric circulation abnormalities will increase the possibility of the storm heading north. Therefore, California is close to multiple hurricane or tropical storm generating areas and is located in the Pacific Rim. Seismic belt, ocean currents, and subtropical high-pressure systems provide favorable conditions for storms to move north. Climate anomalies such as El Niño can also cause frequent storms. The combination of these factors results in California being frequently hit by storms. If climate change causes storms to intensify in the future, California is likely to suffer from extreme weather events of higher intensity and frequency. There are several important things to note when conducting rescue operations after a storm. First, we need to assess disaster risks and determine a safe rescue window period. It is extremely dangerous to go out for rescue when the storm is passing through. Only when the wind weakens significantly and there is a long enough safety window can we carry out the operation. And we should continue to assess risks and be prepared for worse situations at any time. Secondly, choose the right means of transportation. Only professional vehicles with excellent performance are suitable for driving in storm environments. You should choose a multi-purpose vehicle with a strong body, waterproof body, and low center of gravity to improve safety. At the same time, pay attention to road conditions and be alert to traffic accidents. In strong winds, trees can easily break and block roads, resulting in poor road visibility and a high probability of traffic accidents. You should slow down when driving and be alert to various emergencies. If you encounter a traffic jam, quickly judge the situation and retreat to a safe zone. In addition, attention should be paid to hydrogeological disaster risks. Heavy rains brought by storms can easily lead to various secondary disasters. Pay attention to low-lying areas, mountain torrents, etc. Avoid dangerous areas and do not get trapped in them. Currently, countries around the world are constantly developing new and advanced technologies in response to storm disasters. The first is the early warning system. Satellite cloud image technology obtains real-time cloud images through satellites, which can predict the path and intensity of storms in advance, providing a basis for disaster prevention departments to take action in advance. At the same time, high-performance computer climate forecast models use high-performance computers to run climate forecast models, which can predict extreme weather events on a longer time scale and provide assistance for disaster prevention decisions. In addition, Doppler radar is used to monitor strong winds and heavy rains in storms, enabling real-time storm tracking and improving warning accuracy. Radar networks in developed countries have extensive coverage. At the same time, storm warning information is released to the public through wireless communication technologies such as mobile phone text messages and application push, which has wide coverage and improves disaster relief efficiency, such as the wireless emergency alarm system in the United States. More importantly, high-resolution satellite technology is widely used. Use high-resolution satellite images to determine surface characteristics and assess the risk and vulnerability of different areas. Use geographic information system technology to comprehensively analyze terrain, landforms, vegetation, facilities, and other elements to create risk-level maps to provide a basis for storm disaster prevention. There is also a push for unstructured social media analytics. Analyze social media information such as Twitter to assess public concern and panic about disasters and help improve risk management, such as neural network topic modeling technology, etc. What cannot be ignored is the Internet of Things technology. Through sensors installed on bridges, houses, etc., parameters such as wind speed, direction, and water level can be monitored in real time to track the progress of the disaster. In addition, satellite communication equipment can also be used in remote areas to instantly transmit disaster images and videos, allowing the rescue headquarters to fully understand the situation in the disaster area. Launch drones for low-altitude cruising to obtain real-time images of wind or flood-stricken areas to facilitate rescue work. It is worth mentioning that satellite remote sensing technology. After wind and flood disasters, satellite remote sensing images are used to quickly assess damage, assess disaster losses and house collapse, and provide rescue information. Utilize virtual reality and augmented reality technology to build a virtual simulation environment for wind and flood disasters to simulate losses under different disaster intensity conditions and improve the accuracy of assessment. Use machine learning and deep learning algorithms to automatically extract disaster loss information from massive satellite images and ground video materials to achieve rapid assessment. In addition, the use of global navigation satellite positioning systems such as Beidou and GPS can accurately grasp the locations and paths of rescue convoys and medical teams and direct rescue operations. Install radio frequency identification technology on rescue supplies to achieve accurate tracking and dispatch of supplies and ensure the efficiency of rescue work. Use mobile communication technologies such as 4G and 5G to build a dedicated communication network in disaster areas to ensure high-speed and stable communication between the headquarters and rescue workers. In the disaster reconstruction part, new technologies are also constantly emerging. For example, 3D printing technology can be used to quickly print infrastructure such as temporary houses and bridges to help disaster areas speed up recovery and reconstruction. Utilize the non-tamperable advantage of blockchain to establish a transparent donation tracking system to ensure that donations reach disaster victims efficiently and serve post-disaster reconstruction. The most important thing is cloud computing and big data technology. Through the analysis of massive disaster data accumulated through cloud computing and big data technology, we can realize intelligent risk management and rescue decision-making and improve the level of disaster prevention and reduction. Use virtual reality and simulation technology to train rescue personnel, set up various extreme disaster environments, and improve emergency response capabilities. Satellite navigation systems from different countries and regions, such as GPS, Beidou, and Galileo, can be compatible with each other and networked to provide better rescue assistance services. According to the Global Assessment Report released by the United Nations, by 2030, the world will face 1.5 disasters every day, including 1.2 disasters caused by climate change. Failure to take urgent action to slow greenhouse gas emissions will result in more loss of life, property, and social unrest. According to the 2023 Global Risks Report released by the World Economic Forum, governments will face difficult trade-offs among social, environmental, and security affairs in the next few years. Short-term geoeconomic risks are already putting countries' net zero commitments to the test and driving a wedge between scientific necessity and political feasibility. In order to limit the consequences of global warming, the international community needs to accelerate collective action to jointly address the climate crisis. Sea level rise is like a generator for storms and floods. As the sea level rises, the closer the generator is to human settlements. Storms and floods will occur more frequently and violently. Storms and floods will reach further inland. As climate changes, warming oceans can provide more energy for hurricanes, making them stronger and increasing the intensity and reach of storm surges. Therefore, looking to the future, we hope that different countries can strengthen cooperation in disaster prevention and reduction. Professional rescue teams should jointly conduct drills, formulate disaster preparedness plans, establish transnational joint rescue mechanisms, and enhance international cooperative rescue capabilities. Build a unified international large-scale disaster database, collect disaster data from different countries around the world, conduct international cooperative research, and improve global disaster prevention and reduction levels. Thank you for liking, leaving a message, subscribing, and turning on the little bell. We will update the latest news from around the world every day. Continue to use a scientific perspective to explore the complex truth behind meteorological events.